Hello, and welcome to the Toy Car Pre-Lab. So if this were being done in class, as it will be, I would show you the toy car that we're going to use, and we would brainstorm some variables. But since we don't have an actual toy car to use here, I'm just going to show you this little diagram, which works kind of the same. So, what do you notice about the motion of that toy car? Here, watch it again. Well, a couple of things that you might notice. You might notice that it basically is going in a straight line. In physics, we would call that, to use fancy language, one-dimensional motion. That's what we're going to study in this unit, so things moving in straight lines. And then the other thing is that there's something constant about this motion. Now, we don't have certain terminology yet, things that you might use like speed or velocity. And since we don't have those terms yet, we need to break this down into something a little more straightforward. And that is distance and time. So it looks like it's covering about the same distance in the same amount of time. Well, we're going to see if that's true here. So the purpose of this lab will be to create graphical and mathematical representations of the relationship between the distance and the time of the toy car. So is there a relationship that we can find, and if so, can we make a math model out of it to make predictions? Now, you will remember from our study of labs in the last unit that we have, of course, two kinds of variables, the independent and the dependent variable. Right? The independent variable is the one that we control. And really, we could do this experiment either way. We could choose a distance and measure how much time it took to cover that, or we could choose a certain amount of time and decide the distance that it covers. And that's the way we're going to end up doing this lab for purposes that it works a little bit better in terms of interpreting what the graph means. So we are, in other words, going to make time our independent variable. We're going to choose the times, and then we're going to measure the resulting distance the car travels. And again, the reason we're going to do that is because I want the graph set up a certain way. If we go to graph this, since time is our independent variable, it, of course, always goes on the horizontal axis, so we'll have time in seconds. And then the dependent variable goes on the vertical axis, so that's distance in centimeters. So when we get our data done, you're going to create a graph with LoggerPro of distance versus time. Now, we do have one little issue that we need to deal with here in terms of how we're going to do this lab, and that is that these are battery-controlled cars. And of course, over time, batteries run down. And we don't want that extra variable in there. So I'm going to show you a way of running this lab so that you can take all of your data at once and kind of minimize the number of trials you have to do so that we don't have to worry about the battery, the strength of the battery, affecting our results. So here's what you're going to do. You're going to be working on the floor. You're going to pick a line on the floor. That line will be your 0 centimeter line. Okay? You're going to start the car behind the line. You're going to have one person with a stopwatch and one person that's going to be holding these little blocks. Okay? So you'll start the car. When it gets to the line, you'll start the watch. Every 3 seconds, you'll tell the person, and they'll put a little block down on the floor. So you might say, now, now, now. Right? And that person will put blocks down. Once you put all your blocks down, you'll have 6 of them. You can then stop your toy car, and you won't end up running down the battery. And then we can take our time and measure the distances. So that's the 3-second distance. That's the 6-second distance. That's the 9-second distance. So you'll notice here it's not the distance between blocks. It's how far has it gone from 0. Right? So these distances should be getting bigger and bigger and bigger as the car moves further and further and further. And of course, we'll need to gather up all of these things into a proper physics data table. Column headings across the top, units, so time in seconds, which would be 0, 369, something like that. And you can use 2 seconds or 4 seconds, but 3 is probably a good average. And then you're going to do this 3 times. Right? Measure the 3 trials and take an average of those 3 using, of course, correct sig figs. And then you'll end up graphing the average distance and the time. Okay, we don't want the trials. We want the average because the average should help to smooth out any bumps along the way, hopefully. Now, notice how we're doing the lab. Since we're starting the stopwatch right when the car gets to the 0 centimeter line, we do have a true 0, 0 point that we can put in to our data table. And everything should work out well after that. When you are done doing your 3 trials, making all your measurements, taking your averages, going on to Logger Pro and making a proper pretty graph with all the things changed, and remember, if you've forgotten how to do that, there is the laminated sheet near your computer that will help you change column headings, put on point protectors, titles, all that good stuff. Then call me over so that I can get a look at your graph and make sure everything looks good. And then we'll go on with the post-lab. So hopefully today we will get the actual experimental portion of this lab done. Thank you. I hope you enjoyed the toy car pre-lab. Oh, by the way, one very important thing I almost forgot. There is something called a speed dial on the car. Now, I know we haven't defined what speed means yet, so don't touch it. Okay, we don't want to change that. That would change another variable in the lab. We only want to change one thing at a time. All right, so don't touch the speed dial. Whatever it's set at now, leave it set there. Okay, thank you.